Hi students, welcome back. In this video, we're going to investigate different types of curves. Alright, let's start off by visiting the all-time favorite curve. Can you remember what it is? Yes, it is none other than the quadratic curve. Right, and the general form is y equals to ax squared plus bx plus c. Here, a cannot be equal to 0, and I leave it for you to think, what happened if a is equal to 0? Would you still end up getting a degree 2 polynomial? Alright, so how does this quadratic curve look like? It depends very much on the values of a, which is the coefficients of x squared. If a is a positive value, then we're getting a smiling face, a U-shaped curve. In this case here, you will see that we have two x-intercept here, meaning we have two real and unequal roots. We have also learned that it is possible to have two real and equal roots, or two real and repeated roots, or it is possible to have no real roots at all. Right, so this is how it looks like for a quadratic curve when the coefficients of a is a positive value. What happens if a is a negative value? Then we're getting an N-shaped curve, a sad-looking face, and likewise, it's possible to have one that only intersect at one point on the x-axis, right, which means we're getting two real repeated roots, or no real roots at all. Alright, so this is our all-time favorite, the quadratic curve. Alright, so it's time to extend our knowledge to making friends with another type of curve. And this time here, it is the cubic curve. Actually, cubic curve is not new to you because we actually learned this in polynomials in the chapter 4, polynomials. So it's actually not new, but let's revisit it. So cubic curve is in the form y equals to ax cubed plus bx squared plus cx plus d. Right, again, where a is not equal to 0, but b, c, and d possible equals to 0. So this is what we're going to do. We're going to sketch something simple first, where we let b, c, and d equals to 0. So we end up getting a cubic curve, which is y equals to x cubed. Right, so this curve may be a bit new, so we need to have a table. Not the physical table that we're using, but the table of values. Alright. Okay, so I'm going to substitute in some values, some suitable values of x, okay, into y equals to x cubed. Alright, let's start off by seeing how we can get this value y equals to negative 8. Alright, so when I substitute my x cubed to be negative 2, make sure you bracket it, okay. Whatever values you substitute into the equation, and if it's a negative value, please bracket it. So bracket negative 2, close bracket to the power of 3, and that will give you negative 8, which explains this value here. So you can go on to substitute in negative 1, and you get negative, bracket negative 1, close bracket to the power of 3, and you get negative 1 that explains this value, and so on and so forth. Alright, and then how do you think the curve will look like? Let's start off with having the x and y axis. Alright. Even though this is a sketch, it's still important that you label the x and y axis. The intervals must be quite equally spaced out. Otherwise, your curve will look very weird. Alright, so let's start off by plotting the points negative 2, negative 8. So where is the negative 2, negative 8? Yes, that is your negative 2, negative 8. Followed by negative 1, negative 1. Yes. Followed by 0, 0. And that is the origin. Where's my 0, 0? Why is it the cross is not coming out? Okay. Followed by 1, 1. And followed by 2, 8. Alright, so the next thing we're going to do is we're going to join all these points up. And let's see what kind of shape we'll get for our cubic curve. Right, you'll see that you actually get a very beautiful shape. It's like a lady dancing. All right, this part, I don't know, it kind of remind me of, the lady with the hands up, one hand, up in the air, and this is the other arm down with the air, you know. Let me try to draw. Okay, I must confess I'm very bad at drawing. So supposing, I'm sorry. So this is the arm going up, and that is the other arm going down. All right. Okay, so that is y equals to x cubed. All right. What happened if I want to sketch the curve y equals to negative x cubed? What happened? Okay, let's see what happened. So y equals negative x cubed. We're going to use the same values of x, same values of x, same values for the x coordinates. But in this case here, you will see that if x is negative 2, what happened to my y coordinates? I'm going to show it to you. Y equals to negative. There's a negative there, right? Then bracket negative 2, close bracket to the power of 3. You'll get negative bracket negative 8. Because this guy here will gives you negative 8. So negative and negative become positive. Hence, it explains how you get this value here. Okay. Likewise, when x is equals to negative 1, it will gives you y equals to negative, then bracket negative 1 close bracket to the power of 3 gives you negative, oh my god, negative bracket negative 1, and this will become positive 1. Or you can just use your calculator to work this out, save all the trouble, okay, of all the negative and things like that. All right, so let's start to plot the points. So the first point is negative 2, 8. Oh, sorry, negative 2, 8. Yeah. Oh, yeah, here we are. Negative 2, 8 is here. Okay. The second point is negative 1, 1. The third point is our origin 0, 0. The fourth one is 1, negative 1. And the last one is 2, negative 8. Okay, likewise, we're going to join all these points up. And let's see what kind of shape we get. Da, 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 da. Yes, you will see that you will still get the same shape as what we have done earlier on, except that okay, right. So you see that now what happened is that instead of having the young lady with one arms up, it's still one arms up and one arm down. It's just that now we face the other way around. Okay, let me try to draw. Okay, so this lady now go this way, one arm up and one arm down. Right, so this is when your a is less than 0. This is when your a is more than 0. Okay, so this is how your cubic curve looks like when the BCD is equals to 0. Of course, there are other shapes, right? There are other shapes, other possible shapes. For example, it can be, if you have, in this case here, you see that y equals to x cubed. When x is 0, y equals 0. There's only one x-intercept, so there's only one, x-intercept. What happens if you can have two x-intercept? Then your cubic curve may look like this. 3 x-intercept, sorry. This is 3 x-intercept. If it's 2 x-intercept, then it may look like, how do I draw 2 x-intercept? Wait, 2 x-intercept. 2 x-intercept, how do I draw it? Okay, wait, hang on. 2 x-intercept will be, yep, okay, this is how you get 2 x-intercept. This guy here is repeated, this is repeated, and then this is not repeated, or this is be repeated, the other one not repeated, whatever. I think most likely this is repeated because this one is a quadratic curve. Okay, so this is 2 x-intercept, or it could be only 1 x-intercept. 1 x-intercept. Okay, how do you draw one that's 1 x-intercept? One x-intercept. Oh, 1 x-intercept is what I've just drawn for you, lor. Yeah, here. This is 1 x-intercept only. Okay, this shape that I've just drawn for you. Alright, so these are the 3 possibilities. Alright, so we have done with quadratic, we have done with cubic. Let's look at how a hyperbola curve looks like. Yes, it's in the form y equals to 1 over x. Alright, similarly, we're going to have a table of values. Alright, we're going to start off with some values like -2, -1, 0, 1, 2, 3, and let's see what happens. So I'm going to substitute x to be -2. So I would have y equals to 1 over -2, and that gives you -0.5. Right, I'm going to substitute x to be -1, so have 1 over -1, that gives you -1. Alright, the next thing is I'm going to substitute x to be 0, and let's see what happens. Yes, 1 over 0 is something called undefined, which means there's no value for it here. So this is undefined. So we're going to use a different color to indicate it because it's special. Okay, it's undefined. So there's no value for it. So let's go on to substituting y to be 1. You will get 0.5. Substitute. Sorry. If you substitute 1 to be 1, 1 over 1 is 1. What am I talking? 1. Substitute 1 to be 2, you get 0.5. Substitute 3. It will be 1 over 3. That is that's 1/3, right? Which is 0.3. Okay. So you can see that alright, when x get bigger, okay, let's do some kind of observation, not observations, analysis. Can you see that when your x value get bigger and bigger from this part of the curve, right? When the x increases means x get bigger and bigger, you will see that the values of y decreases. Okay, from 1 becomes 0.5, 0.3, right? It decreases. Whereas the other part of the curve, it has a different meaning. When your x get smaller, your values of y increases. Okay, -2 is smaller than -1, right? So when the x gets smaller, the values of y, -0.5, it's bigger than -1. Okay, so these two information is very important that will help you to sketch this hyperbola curve. So let's start off by having the x and y axis. Okay, I'm going to try to draw the best vertical line ever possible. Okay, cannot, a bit slanted. Let me try again. Okay, let's do a good job. Alright, not so bad. I'm going to try to draw the best horizontal line. Alright, okay. Let's label the x-axis and the y-axis. Alright, the origin. I need to draw this guy longer a bit. Okay, so I need to have 1 here, 2, 3, and then -1, -2. Okay, what are the values of y, which is 1, 0.5. So we can start off with 0.3. 1, 2, 3, 4. So 0.5 will be somewhere here, and 1 will be here. Okay, so that will be -1, -0.5 is here. Alright, so even though this is a sketch, it's important that you space out the intervals. Okay, the intervals space it out evenly. Alright, okay. Let's start off by plotting the first point, which is -2, -5. -2, -5 will be here. Okay, -2, -5. Second point is -1, -1. Okay, -1 will be here. Okay, right. So how do you think it will look like if you just join these 2 points like that, right? Then of course the curve kind of doesn't make sense, right? Yeah, you can't really see the shape. So like what we have analyzed early on, this is very important. When your x gets smaller, the values of y get bigger. When x gets smaller, the values of y increases. Yeah, right. So I need to extend this longer. That means when the values of x get smaller and smaller, like from -2 they become -3 to become -4, the values of y get smaller and smaller, become negative 0.1, negative 0.01, negative 0.0002 gets more bigger and bigger. So it goes this way up. Okay, and then when your values of x get bigger and bigger, the values of y will get smaller and smaller. So it comes down like that. Okay, and the important thing that you must take note is that you will never, can you see that the red curve will never touch the y-axis. You'll never touch the y-axis because 1 over 0 it's undefined. Okay, if you let your x to be 0, you get 1 over 0 undefined. And if you let your y to be 0, likewise also you have, okay, you see, all right, let me try to explain. You see, if you have y equals to 1 over x, right? If I just do a cross multiply, I would get x, y equals to 1, I'll have x equals to 1 over y. Okay, so you see, this situation here, if I want to find my y-intercept, means if I let x equals to 0, I have 1 over 0, I have my y-intercept, which is 1 over 0 undefined. So it does not touch the y-axis at all. There's no value for the y-intercept. 1 over 0 undefined. So there's no value for y-intercept. Okay, there's no value for y-intercept. Therefore, this red color line will not touch the y-axis. Likewise for the x-intercept. X-intercept is when I substitute my y to be 0 here. Substitute my y to be 0, I get x equals to 1 over 0, which again undefined. So there's no x-intercept, there's no y-intercept. Okay, so for this curve, there's no x-intercept, there's no y-intercept. So therefore, your curve just go this way like that. Okay, so this is this part of the curve where your coordinates of x is a negative value. What happens if your coordinates of x is a positive value? Okay, let's see what happens when x is 1, y is 1, x is 2, y, okay, x is 3, 0.3. Okay, similarly, okay, when you join them, you'll get a curve, right? So you see, just now we already mentioned there's no x-intercept. So your curve again will not touch the x-axis. It has no y-intercept, so it will not touch the y-axis also. So this is how your hyperbola curve looks like. Okay, for y equals to 1 over x. Alright, it will look like this. Go this way and go this way. This is y equals to 1 over x. Then we're going to extend this knowledge to y equals to negative 1 over x. How do you think the curve will look like? Yes, you will still have two curves. It's just that the quadrant will be different now. When you have y equals to 1 over x, the quadrant is in the first. This is the first quadrant. This is the second. This is your third. This is your fourth. So when you have y equals to 1 over x, the curve is in the first and the third quadrant. If you have y equals to negative 1 over x, then the curve will be in your second and the fourth quadrant. Okay, it will be different. You can always have the same table of values, but in this case here, you just make sure you have a negative there, and you will be able to get what I've shown here. Or you can just go to Desmos, which is a very, very good application. GeoGebra or Desmos, any of those apps where you can use a graphing calculator, and then you can just key in the hyperbola curve, y equals to 1 over x or y equals to negative 1 over x, and you can see the shapes. Alright, we're going to do the last type of the curve, and that is we're going to sketch the curve for y equals to 1 over x squared. Alright, so we're going to see how this curve looks like. Right, so we're going to substitute x to be negative 2. So when x is negative 2, we will have y equals to 1 over bracket negative 2 close bracket squared, and that will give you 1 over 4, that is 0.25. Okay, then you continue for negative 1, so y equals to 1 over bracket negative 1 to the power of 2, that gives you 1. Okay, similarly, when you substitute x to be 0, similarly means you will have something called undefined, which is similar to what we have done earlier on. There's no value for it. So this one is special. So we're going to use a different color to indicate how special it is. So this is undefined. Okay, and then if you continue for x equals to 1, so 1 over 1, it's 1 over 1 squared, it's 1. 1 over 2 squared would be 0.25. When x is 3, y equals to 1 over bracket 3 close bracket squared. That gives you 1 over 9. I think it's 0.1. I don't have a calculator with me, but I think it's 0.1. Just put to one decimal place. Because it's a sketch, you can't actually have two decimal. Oh, you can now, because 0.25 is two decimal places, right? Just estimate a value, okay? So if you want 0.11, let me verify if it's correct. I think so is correct. But I think we should verify it. Where's my calculator? Oh, I didn't bring my calculator, but I think it's correct. Okay, the next thing is let's draw the x and y axis. Let's see whether I can draw the best vertical line possible. Because if you remember what I told you, I can place a ruler. I basically just can't touch the screen. It's just the tip of the stylus pen touching the screen only. Oh, very good. It seems that I've drawn quite very straight lines. Okay, let's label your x-axis. So we have 1, 2, 3. The other one it's -1 and -2. Alright, so we have 0.5, 1 unit, -0.5. Oh, okay. What is the if you were to examine your y coordinates, do you see what I've seen? Yeah, there's no, all these values are positive values. So there's no negative values for y. In fact, that means your curve is entirely above your x-axis. Okay, let's look at this part of the curve first, right? Let's look at analysis. This part of the curve, you see that when x increases, that means when the values of x get bigger and bigger from 1 to 2 to 3, the values of y decreases. Okay, so for this part here, it's when x get bigger. It's the other way around. It's the other way around. It's when x decreases, your y get bigger. It's the other way around. And similarly, when you let x to be 0, there's no x-intercept, also no y-intercept. Because when you let x to be 0, 1 over 0, it's undefined. And if you let, if you were to do this to find your y-intercept, what am I doing? Sorry. I need to find x as subject, make x a subject. Okay, so if you're going to find y-intercept by letting x to be 0, you have 1 over 0, which is undefined, so therefore there's no y-intercept. And if you're going to let y equals to 0 to find your x-intercept, again you have x equals to 1 over 0. Again, it's undefined, so there's no x-intercept. So this is a kind of similar situation where we have for the hyperbola 1 over x. Okay, so let's start off by plotting the points. So we have 1, 1 point here, 2, 0, 5 here, 3, 0.1. Okay, it gets smaller and smaller. When x gets bigger, your y gets smaller and smaller. So there's no y-intercept. So again, your curve will not touch your y-intercept, and you will also not touch the x-intercept because there is no x-intercept. Okay, so how about the other part of the curve? -1 will give you 1 here, 1 point, -2, 0.25. Yeah, so the other part of the curve will be this. Okay, wait, hang on. It does not touch the x-axis. Let me draw again. Alright, so this is how your curve looks like for 1 over, for y, this is y equals to 1 over x squared. Okay, there's no x-intercept, there's no y-intercept. Okay, so that's why your curve will not touch the x-axis, will not touch the y-axis. So how about y equals to -1 over x squared? What do you think the curve will look like? Yes, the curve will look like this way. It will be entirely below your x-axis because all your positive y coordinates, when you multiply with the negative, will become negative. So here will become negative 0.25, -1, -1, -0.25, -0.11. So therefore your curve will be entirely below the x-axis. Okay, right. So Right, so let's do a summary of what we have done so far, what we have learned so far. Okay, I'm going to have a divider and then another divider. All right, so we have learned quadratic curve. This is quadratic. Okay, if your a is more than 0, this is how it looks like. A is less than 0, this is how it looks like. Okay, and then we have learned cubic. Cubic is y equals to ax cubed plus bx squared plus cx plus d. Okay, this is a cubic curve. Alright, a more than 0, it will be a lady with one arms up, one arms down. If a is less than 0, the same lady, but it's the other way around. Now the arms is go this way and then down. Okay, and then we also have learned our hyperbola curve, which is y equals to 1 over x. It will go this way. There's no x-intercept, no y-intercept. So first and your third quadrant. Okay, make sure it does not touch the axis. If it's y equals to negative 1 over x, then it will be second quadrant and the fourth quadrant. And then we also learn this curve. I don't know the name for this. Y equals to 1 over x squared. So it will go this way. Let's use a different color. It will be entirely above the x-axis. It's just two persons sitting back to back. You can just imagine, you and your best friend sitting back to back. Make sure it does not touch the x-axis and the y-axis. If it's y equals to negative 1 over x squared, then it will be entirely below the x-axis. Alright, so these are the curves that we have just learned. Alright, good luck.